Hello again, this is Unit 9b, Derivations Continued. Sorry about the abrupt end to 9a. The recording software I'm being provided with is having some technical difficulties, so there may be some chops. I do apologize for that. Okay, so the main thing we're going to talk about in this video is about new subderivation strategies, or sort of subderivation strategies. So you can do show unneg of any complex negation. So if you have not P and Q, one thing, if you have a De Morgan's rule derived, you might have one that you could apply to this, but otherwise you could show P and Q, and the show unneg command would work just as is for that. You could show the other sort of basic new subderivation is show neg dist, and we use that if you have an unused disjunction. So remember that the elimination rule for P and Q is MTP, and that to do MTP with P or Q, we need either not P or not Q. So in other words, we need the negation of one of the disjuncts. So we could try, if we have an unused disjunction, we could try to do a subderivation of not P or of not Q. Right, so here we have the P or Q. We have either not P or not Q. We can infer Q or P, so what we want to get is the not P or the not Q. So in chapter 1, this is analogous to show ant in chapter 1, because if we had an unused conditional, we could do show ant to show the antecedent of the conditional to then do modus ponens with the conditional. So here, show neg disjunct when completed will let us use unused disjunctions. And I'll give an example of that. We'll do an example derivation as another video, and I'll have the an example of that in that video. So we've talked about derived rules before. A derived rule is enabled by deriving the associated theorem, which is a problem in the derivation module. Any derivation can be done without the use of any derived rule, and that's why we're allowed to use them. You might wonder, well, why bother? And the answer is that derived rules make many derivations much easier because they summarize a bunch of reasoning you might have to go through again and again and again. And instead, we do the reasoning once, and then we can appeal to it later because we've done it. You might say, what would be some useful derived rules? Well, here's a list. I'll have this will be in the attached slides, but it will also be available as a separate handout online. So we can see there's one category which is almost essential, and that's one version of DM. It's the version of DM that says if you have a negated disjunction, you can turn that into a conjunction of negations, and vice versa. And this is really important because it's very helpful when we're trying to show a disjunction. We assume ID, and then we have a negated disjunction, and what are we going to do with that? Well, the easiest thing to do is, once we have DM, is apply this rule. Now, there are a bunch of versions of DM. Once you've derived one, you don't need to tell it which one to use. You can just enter DM. You don't have to say DM2 or DM4. The program, if multiple versions are applicable, it will ask you which one you want to use, but you don't need to enter the numbers. And then we have, not quite as essential, we have DM13, which applies to negated conjunctions and turns them into the negation, a disjunction of negations, or again, vice versa. We have the rule NC. It says if you have the negation of a conditional, that's equivalent to the conjunction of the antecedent and the negation of the consequent, right? When is a conditional false? When and only when the antecedent is true and the consequent is false, and NC takes us in both directions there. And finally, NB says if you have a negated biconditional, then you can move the negation inside to one of the components and vice versa. This should make sense. If the biconditional is false, then the P and the Q have to have different truth values. If they have different truth values, then the negation of P and on the one hand and Q on the other are going to have the same truth values. These are useful because in all of them, they help us work with the negated formula, and they help us move the negation inside. If you don't have these, you have to do show unneg. Once you have these, you can apply these rules instead of show unneg. So they're quite useful because they're an alternative to show unneg. MC is helpful because it lets us infer a conditional. If you have Q or not P, you can infer the conditional. The BP and BT rules are very, very easily derivable, and they're just make using biconditionals easier. So if you have a biconditional and you have one side, you can just directly infer the other without going through the component conditionals. And again, if you have the biconditional and you have the negation of one side, you can infer the negation of the other. And then there are other rules. The CJB and NCJ rules are easy to get. They're very straightforward. The separation of cases, the SC rules, the CDJ rules, also useful rules, can be handy at times. So I would say definitely derive DM24, and I would say almost certainly derive the other DM13 and NC and NB. And then BP makes your life a lot easier, and it's very easy. And the other handy and straightforward ones are also worth deriving, but the most important ones are the negation ones. So I'm going to go ahead and end this video, and I'm going to do a derivation example that's going to involve show neg disjunction or disjunct, and also